So we didn't have a quiz, we just got to get used towards population and sample, and also looked at some ways to present data to people. So we looked at these tables that you have your samples placed into. Remember, there was a little table here, 12.2, where you broke your sample into various classes. So that'd be the practice that we're going to do today. We're going to produce classes, and then we'll summarize data from class in order to produce this nice bar graphs, so-called histograms. So we're going to get those tables that were also named as distributions. And then we'll see what else we can do to present the data to people so they understand better what is going on. So I'm gonna start here with exercise like number 7, I think will be a good start. And see how we can work with a sample of 30 college students, and then the following times in hours obtained, how much they spent doing the homework according to their responses. So it looks like I will go with the sample that seem to range between 15 and 24 hours. I try to find the smallest and the largest values of the sample, and looks to me that smallest is 15 and the largest is 24 in here, right? So in order to be able to produce the nice picture of all that, I need to have start with 15 and end at 24. So I can find the sample range here, which is always the difference in between the largest and the smallest sample elements. And when I subtract from the largest, from 24, the smallest number 15, then I can see that range is going to be 9. So now I need to break this into various categories like they do here, or classes. And I would suggest to use 4 classes for this exercise. Main reason is I always try to use 4 because you cannot use less. Less is going to be not enough, but 4 turns out as an optimal number of those so-called classes. So what I'm going to do is find so-called class width, so we can see how wide each class is. And to be able to do this, I divide range by number of my classes. So I cut this range into 4 pieces. So you can say divide in general by number of classes. So that's a general direction how to present your data. So when I do this division of 9 by 4, I get about 2 and a little something, right? 2.5, I guess, right? 2.5. Or no, 2 and a quarter. Should use calculator for this. So I divide my range, which is 9 by 4, and this will be 2.25. Well, please notice that 225, that's not very convenient number to use. So what I can do is round it to approximately 2. So I can say that each class will be of the width of 2. When you say, well, your last class will be a little bit wider. Yeah, a little bit wider, but I would like each class to be pretty much of the same width. So when I see where my first class starts and ends, I'm gonna add the 2 with 15 and get 17. And so forth. So I can add 17 with a 2 and get 19. Right? I get to add another 2, get 21. And then my last class will end at 24. So that's how I start this process. So I can prepare a little table here so we can see that classes are going to start at 15, 17, 19, and finally 21. And then end at 24. That's where my sample will end. Well, my previous class should be ended at 20. Main reason is that these classes should not touch each other. So if I end it at 20, then the next will start at 21, so they're not going to be intersecting classes. So analogously, I'm going to end second at 18 and the first class at 16. So this way, my classes are not going to be intersecting. And I'll need to find the word frequency, right? Remember, number of elements in each class is called a frequency. So I need to see how many 15s and 16s will be here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements is in my first class. So frequency here will be 9 because it looks like there are 9 elements in the first class. So it looks like there is a little bit of a challenge to produce these frequencies if your sample elements are so well mixed. Well, we just do our best to produce them. So next, we'll deal with 17 and 18, right? So let's see how many will be here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 elements that belong to my second class, 11 elements that in between of 17 and 18, right? So next class will be 19 through 20. So analogously, I'm gonna see what's going on in here. So looks like we have a little less elements here. 1, 2, 3, 4, 5, 6. Okay, 6 elements is here. And finally, whatever remains must be in my last class, right? 21 through 24. So let's see. 1, 2, 3, 4 elements will be here. Okay. So the question is, did I do this right? Did I have my entire 30 students correctly distributed? And the way to double check this is to see if my so-called sample size or total number of elements in the sample will be equal to 30. So if I add all of these numbers together, 20 and 10, yes, I will get 30. So this is a really correct distribution. So remember the name for this table? It's a frequency distribution. So we see how our sample is being distributed. So we break this into non-intersecting classes. And this is all being done to answer a question of this exercise that wants me to make a picture, or actually we just constructed distribution. So that's the answer. But I still want to make a picture. I say, Alex, why do you want to make picture? Well, because my goal was to show how this whole thing is distributed. Remember on the previous pages, we saw this so-called histograms. Where are they? Let me show you that histogram. So that'd be nicer presented. You can see this green bunch of bars that they have here for us. And that's exactly what I'm trying to get, so-called histogram. So the way to produce a histogram is to select the largest frequency, which is 11 here. So I'm going to use 11, the largest. So let me put another color so better see this. 11. And I'm going to, with respect to this largest frequency, put all of the others, such as 9, which is a little bit smaller number, right? We also see 6, and we also see 4. So our first bar that starts from 15 through 17 will be somewhere here of the height of 9. So now I'm gonna try to make a nice intuitive picture that corresponds to this table, to this distribution. So the next bar will be of the height 11. That's the tallest from the bars that I have, right? That's largest frequency. Now about the height of half of it, like a 6 will be my next bar. So half, just 6. And finally 4, the shortest, 4, that is last bar. That happens to be a little bit wider because it actually has a extra 1 in width, but that's fine. Please notice that these last bars usually don't have as many elements anyways. So I got my picture, and that's what's called as histogram. Okay. Histogram. And we have the distribution pictured. So I just designed an example of this distribution, and I want you to notice one very important fact, that we always need to have total of frequencies as our sample size. So that's a very important observation to make. So this way you don't lose any of your elements of data. So in some of the exercises, they actually don't tell you the sample size. They just give you table. So what you can do is actually find how many sample elements were considered in here. So what I can do is try to not do the exercise, but find what was the sample size for this particular example. Well, all I have to do is add my frequencies. So I need to add 12 with 16 with another 16, etc. Dot, 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 all the way to 3. So let me see what this is. Let me try to add them. So how to better add them? I can add 6 and 4. That's a nice, because it's going to be 20, right? And anything else? Well, looks like not much, not many nice pairs. Oh, maybe I can also add these 11 and 3 and 3 and 3. So that'd be another 20, right? Okay, so let's see what is left. Another 10, that's so 20 and 20, 40 and 10 is 50. And 2 16s, that's 32. So that's going to be 82, right? Actually, I need to just add the last digits. So I'm going to add this, so it'd be 20 and 20. So that's 40 and another 0. So not 10, but 0. I just add my last digits, right? Or you could just use a calculator, right? So it'll be 40 and then 2 6s, so it's 12. So it'll be 52 and a 2, which is going to be 54. So I put 4 here and I carry 5. So I'm going to add 5 and 1, 2, 3, 4, 5, 6 ones. So 5 and 6 is 11. So it looks like sample size is 114. And again, suggestion is double check this with your calculator. So let me try to do this again in that table. Find a sample size. Add all of the numbers and see what be the total. So I think that these two will be good to add 12 and 18, right? So it'll be like 30. And then I add 16 with 3 and 1, 16 and 4, that's 20. So with 30 is 50, and there's 2, so it's 52. So the point of story, you don't need to know what the sample size is. All you can do is add the frequency and find the number of elements in your sample. So I think it'd be a good idea if you try to find the sample size n for this particular table. So can you tell me what be the sample size for that table as a little quiz for today? In other words, how many elements we actually have in the sample that I just circled here with red. So that'd be our little quiz. Please don't hurry, try to do this right. You can use a calculator, why not? So I'm gonna stop this recording.